In the 19th century, swarms of Rocky Mountain locusts crossed western North America. Farmers feared them. Then the swarms stopped appearing. By 1902, the last known living specimens had been collected in Manitoba. A species once known for outbreaks had disappeared, leaving a mystery behind. The Rocky Mountain locust was a short-horned grasshopper known as Melanoplus spretus. Historical records place it across western North America, in the United States and Canada. It was not famous because it was rare. It was famous because, at times, its numbers transformed the sky and the ground. The exact ecology of a vanished insect cannot be watched again, but the extinction research points to a crucial detail. Eggs and young insects were concentrated in small riparian habitats late in the species' history. Rivers and stream banks may have mattered far more than the vastness of the plains suggests. Before 1900, the Rocky Mountain locust was one of the most serious agricultural pests in the western United States and Canada. Migratory swarms periodically moved out from the northern Rocky Mountain region. Crops lay in their path. The records describe an insect feared across a continental landscape. People fought the outbreaks with the tools they had. But the more surprising part of this story came later. A species can be visible enough to shape farms and livelihoods, yet still disappear before anyone understands the places it needs to reproduce. Abundance did not make it safe. In the late 19th century, the big outbreaks ended. The species entered a sharp decline and never recovered. Scientists can reconstruct parts of the story from records and specimens. They cannot watch the final collapse unfold. That gap is why the disappearance remains an ecological mystery. The last known living Rocky Mountain locusts were collected in Manitoba in 1902. A collection record is not a filmed ending. It tells us where and when specimens were taken, not the exact moment the species ceased to exist. After that, no confirmed living population returned to the record. One leading explanation begins after the population had already crashed. Lockwood and Debray propose that its remaining breeding range may have become compressed into river-edge habitats. Tillage, irrigation, the loss of beaver, and introduced species changed many of those places. This is a carefully argued hypothesis, not a verdict. Extinction stories often invite one simple answer. This one does not have it. Broad changes in climate, bison, people, and grazing have all appeared in discussion. The strongest published argument focuses on local breeding habitat after a natural crash, but the exact chain of events remains uncertain. Museum drawers preserve insects collected when the locust still lived. Glacial deposits also held older remains. Those fragments let later scientists examine a species that was gone before modern conservation systems existed. The evidence is incomplete, but it is real, and it can still answer new questions. DNA from old material helped test two questions. The study found that loss of nucleotide diversity could not be treated as the cause of extinction. It also challenged a simple relationship to one living migratory grasshopper without settling every taxonomic question. Science narrowed the mystery. It did not erase it. The Rocky Mountain locust shows why abundance can be misleading. A species may fill records, fields, and memory, yet depend on a small part of the landscape at the wrong moment. Its disappearance deserves honest uncertainty, not a convenient ending. Next, we visit San Francisco's lost Xerces blue butterfly. Subscribe for the next story from a vanished world.